The objective of this challenge was to create a capacitor that has a capacitance and measure it theoretically and experimentally. To measure it experimentally, we're going to use a capacitometer.
In order to build this capacitor, we took two pieces of aluminum paper, two squares, and also a toilet paper cylinder, and then we roll one of them around the cylinder. Then we took acetatum paper, and also we rolled around the cylinder, and then another layer of aluminum. Then we attached two cables, one to one aluminum and one to the other one.
Okay, in order to obtain the data from the cylinder, we measure the length and both of the radius. We search for the dielectric constant, and then with the formula of the capacitance of a cylinder, we input those values here. We obtain that the capacitance, theoretical, it should be 7.41 times 10 to the minus 10 farads.
In order to calculate the capacitance of our capacitor, we used a capacimeter and we connected it to each end of the cable. We obtained 8.08 times 10 to the negative 10 farads. For us to be able to get a decent result, we had to use the correct scale in the capacimeter to be able to recognize the amount of farads.
Our capacitor generates capacitance because, as you can see in this drawing, you have one aluminum plate with the positive charges when you input the voltage, and the other one with the negative. And if you take away the voltage, you got left with one aluminum just with positive charges and the other one with negatives. And in between, you generate an electric field. That makes capacitance. And then if you input a dielectric in between them, the molecules, the negative ones goes towards the positive ones, and one of the positive ones goes towards the negative. This thing increases the capacitance and also the charge.
As we can see, the capacitance as we obtain is exactly what we expect, because it's something made in homemade, and the percentage of error that we obtain, we actually think that is because it's kind of difficult to measure this thing, and some decimals that we lost.
Our objectives were successful since we were able to build a capacitor and generate a capacitance, and we were able to measure it with a 9% error that we think is pretty good.